Welcome to the lab of Dr. Erin Gross. My name is Sarah, and I am working on an analytical chemistry project in this lab, a project that I would consider green because of the amount of solution we use every day is very small, and we do everything on a micro scale. We actually used to have a bigger system. I can show you in the lab. There's this Faraday cage, that's the large black box you see in front of me. It's a cube about 3 feet on all sides, and the solutions and reactions that we did in there required a lot of solution. So we did have maybe liters of waste every week or every month, depending on how often you ran the system. However, we've downscaled to what you see in front of us. The black box contains our system. And if we look inside of there, you can see there's not actually a lot in there. What we do see, however, on the left-hand side of this box is a PMT photomultiplier tube to collect light and a microchip sitting directly on top of it. Attached to that microchip is a piece of tubing that is connected to this injector. This injector in front of you is a microinjector. There is a loop that injects a 0.5 microliter sample that can be sent through the tubing and across the flow channel of the microchip. 0.5 microliters is a very small amount. To put it in perspective, a drop of liquid is about 25 microliters, so it's about 50 times smaller than that. I actually have another microchip sitting out on the counter here, and it'll give you a better view of what one looks like. This microchip, it has a glass slide on the bottom for support, and then a layer of PDMS sitting on top of it. That's a little hard to visualize. On that layer of PDMS, there are 3 electrodes, a working electrode, counter electrode, and reference electrode, which were imprinted into the PDMS, and then carbon paste was put into those. Each of those 3 is connected to a wire, which we connect up and run a potential through there. On the very top, you can see this flow channel, and the flow channel is what's connected to the tubing from the injector so that a sample can be run through there and the amount of analyte can be detected. So looking back at the system, you can see how small everything is. We start with our pump, which has a small syringe on it. The syringe is only a 1 cc syringe. In a given day, we probably only use about 10 milliliters of solution, and that would include all of the water for rinsing and your analyte. Usually we use such small concentrations of anything that by an end of the summer of research, I had about 200 milliliters of actual waste. So you can see that everything is done on a very small scale. We're working on developing these glucose sensors so that they can be cheap and portable and also green for our planet.